Hi everyone, my name is Emily and this is Andrea. We're going to talk about our work analyzing videos of VR fails on YouTube. We did this work with our co-authors Kasper and Jarrod. As virtual reality grows in popularity, we are seeing the rise of community content showcasing its use. In contrast to research labs which are easy to control with specific furniture or layout, domestic and public spaces are messy, busy and dynamic. YouTube is rife with videos of players interacting with VR in household and community spaces. We see people colliding with furniture, falling over, hitting spectators, and experiencing fear, surprise, joy, and more.
We watched many of these videos to better understand the phenomenon surrounding VR fails. Specifically, we were interested in thinking about VR fails from two perspectives. First, we consider VR fails as breakdowns, which are moments of stark disruption in the experience. In this case, fails indicate usability problems, causing users to express surprise or uncertainty of how to engage with the technology. From this perspective, we aim to identify how we might design to avoid fails and solve these usability problems. On the other hand, we think about VR fails as seamful design, suggesting that fails are not just problematic, but rather they provide insights into the motivation and enjoyment of VR use.
We analyzed 233 of these videos to identify themes around how people fail and what causes these fails. We identified 6 types of fails. You can see them here, together with the percentages of their occurrences in our dataset. We saw people making excessive reactions, falling over, hitting with hands, colliding, coverings, and other types. The most common type of fail that we saw was excessive reaction. These often involve user flailing around or screaming, often being caused by sensorimotor mismatch or fear. Notably, it is typically the spectators that experience excessive reaction as fails. For the players, they form a natural part of the interaction. Many of the actions observed here fall outside of the game design, but they can still be considered expected behaviors. Moving to the causes of these fails, we found 7 causes. We observed that these fails were most commonly due to fear, followed by sensorimotor mismatch, obstacles in the real world, crowd participation, false signifiers, setup failures, and in some cases, no cause.
One of the most common causes of fails is sensorimotor mismatch. In this case, sensory information, primarily visual and proprioceptive, doesn't match the player's movement. The mismatch can be due to latency or visual-only feedback. This cause often appears for users playing roller coaster games, which usually ends up in players falling over or showing excessive reactions.
Having examined these fails as both breakdown and seamful design, we discussed new design opportunity they inspired. As breakdown, some of these fails can be pretty dangerous, causing harm to spectators and players alike. We saw so many videos of spectators being hit by players. Recent work in HCI has explored sharing the view with spectators through head-mounted projectors. To reduce the risk of hitting fails, we suggest using these projections to notify onlookers about the player's next likely movement. This might let the spectators avoid collision with the players or arrange the physical environment to prevent the players from hitting and damaging the furniture.
As seamful design, VR fails can reveal new interaction opportunities. We see players perform actions like curling or covering by instinct and suggest adding these actions as controls in VR. For example, peek-through mode could allow players to disable the display by covering their face, only partially revealing the view as they peer through with their fingers. Our paper reveals our analysis, insight, and design ideas in detail. Thank you for watching.